Scuba diving is a mode of underwater diving in which a scuba diver uses a self-contained underwater breathing apparatus to breathe underwater. Unlike other modes of diving, which rely either on breath hold or on breathing gas pumped from the surface, scuba divers carry their own source of breathing gas, usually compressed air, allowing them greater freedom of movement than with an airline or diver's umbilical and longer underwater endurance than breath hold. Scuba equipment may be open circuit, in which exhaled gas is expelled to the surroundings, or a closed or semi-closed circuit rebreather, in which the breathing gas is scrubbed to remove carbon dioxide, and the oxygen used is replenished from a supply of feed gas before being rebreathed. A scuba diver primarily moves underwater by using fins attached to the feet, but external propulsion can be provided by a diver propulsion vehicle, or a sled pulled from the surface. History. By the early 20th century, two basic templates for scuba had emerged. Open-circuit scuba, where the diver's exhaust is vented directly into the water, and closed-circuit scuba, where the diver's unused oxygen is filtered from the carbon dioxide and recirculated. Rebreathers. The closed-circuit rebreathers were first developed for military use, due to their stealth advantages. The first commercially successful closed-circuit scuba was designed and built by English diving engineer Henry Fluce in 1878, while working for Scuba Gaussman in London. His SCBA consisted of a rubber mask connected to a breathing bag, with 50 to 60% O2 supplied from a copper tank and CO2 scrubbed by rope yarn soaked in a solution of caustic potash, the system giving a duration of about 3 hours. Sir Robert Davis, head of Scuba Gaussman, perfected the oxygen rebreather in 1910 with his invention of the Davis submerged escape apparatus, the first practical rebreather to be made in quantity. Rebreathers have been increasingly used by civilians for recreation, especially since the end of the Cold War. This reduced the perceived risk of attack by communist bloc forces, including by their combat divers. After that, the world's armed forces had less reason to requisition civilian rebreather patents, and automatic and semi-automatic recreational diving rebreathers started to appear. Open-circuit scuba. The first commercially successful scuba sets were the Aqualung twin-hose open-circuit units developed by Émile Gagnan and Jacques-Yves Cousteau in 1943. The single-hose two-stage scuba regulators trace their origins to Australia, where Ted Eldred developed the first example of this type of regulator, known as porpoise scuba gear. This was developed because patents protected the Aqualung's twin-hose design. The single-hose regulator separates the demand valve from the cylinder, giving the diver air at the ambient pressure at the mouth, rather than ambient pressure at the top of the cylinder. Etymology. The term scuba originally referred to United States combat frogmen's oxygen rebreathers, developed during World War II by Christian J. Lambertson for underwater warfare. Scuba was originally an acronym, but is now generally used as a common noun or adjective. Scuba. It has become acceptable to refer to scuba equipment or scuba apparatus. Examples of the linguistic Rast syndrome. Applications of scuba diving. Scuba diving may be performed for a number of reasons, both personal and professional. Recreational diving is performed purely for enjoyment and has a number of distinct technical disciplines to increase interest underwater, such as cave diving, erect diving, ice diving and deep diving. Divers may be employed professionally to perform tasks underwater. Some of these tasks are suitable for scuba. Professional scuba divers are trained to manage situations in which they may face vertigo or entanglement. There are divers who work, full or part-time, in the recreational diving community as instructors, assistant instructors, dive masters and dive guides. In some jurisdictions, the professional nature, with particular reference to responsibility for health and safety of the clients, of recreational diver instruction. Dive leadership for reward and dive guiding is recognized and regulated by national legislation. Other specialist areas of scuba diving include military diving, with a long history of military frogmen in various roles. They can perform roles including direct combat, infiltration behind enemy lines, placing mines or using a manned torpedo, bomb disposal or engineering operations. In civilian operations, many police forces operate police diving teams to perform search and recovery, or search and rescue, operations and to assist with the detection of crime which may involve bodies of water. In some cases, diver rescue teams may also be part of a fire department, paramedical service or lifeguard unit, and may be classed as public service diving. Lastly, there are professional divers involved with underwater environment, such as underwater photography or underwater videography divers, who document the underwater world, or scientific diving, including marine biology, geology, hydrology, oceanography and underwater archaeology. The choice between scuba and surface-supplied diving equipment is based on both legal and logistical constraints. Where the diver requires mobility and a large range of movement, scuba is usually the choice if safety and legal constraints allow. Higher-risk work, particularly in commercial diving, may be restricted to surface-supplied equipment by legislation and codes of practice. Diving activities commonly associated with scuba include depth range. The depth range applicable to scuba diving depends on the application and training, but most recreational dives are 30 meters deep or less. Recreational dives are limited to no-stop dives or relatively short planned decompression stops to minimize risk of decompression sickness. Recreational scuba is generally limited to depths of no more than 42 meters or 50 meters. Professional diving also limits the allowed planned decompression depending on the code of practice, operational directives, or statutory restrictions. Depth limits depend on the jurisdiction, and maximum depths allowed range from 30 meters to more than 50 meters. Depending on the breathing gas used and the availability of a decompression chamber nearby or on site. Technical diving may involve exploring the logistical and physiological limits, and in these cases a higher risk is accepted by the diver, and considerable effort may be made to reduce this risk by careful planning and contingency procedures. Depths are limited by physiological and logistical aspects, the amount of gas that can be carried, gas mixture, decompression requirements, narcosis and oxygen toxicity at high pressure, and work of breathing constraints.